Hi everyone, welcome back to Nuskrit. So let's solve today's daily LeetCode challenge, which is product of array except self. So let's try to read the problem statement first. So we are given an integer array nums. We need to return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. This simply means that we can simply take an integer type of variable, right, to store the product at any point in time. Like we don't really need to take a long array, right? So we can simply take an integer array, right? So now you must write an algorithm that runs in big of n time and without using the division operation. So there's a constraint that we cannot use division operator, right? So that means we cannot like calculate the product of the entire array and then divide it by that particular ith element, right? So we cannot do that. So let's look at an example. So if this is 1, 2, 3, 4 an array, so 24 is because the product of the entire array except 1, right? So 2 into 3 into 4 is 24. Then again, the product of entire array 3 into 4 into 1 and except this 2, right? So 3 into 4 into 1, which is 12. Then except this 3, we need to multiply the entire array, which is 1 into 2 into 4, which is 8. Then except 4, we need to multiply the entire array, which is 1 into 2 into 3, which is 6, right? So I hope the problem statement is clear. So we will be solving this problem using 3 different approaches, and which will be a like brute force and then better and then optimized solution, right? So let's look at a very first approach. So approach 1 is where we will be using 2 different left product and right product array, right? So the idea is very simple. So what we will do is basically we will take an left product array and right product array. And in these two arrays, we will try to store the product of left side, right? So as you can see at this point in time, like at index 4, we are kind of storing the product of this entire array, like which is very, very simple, right? So what we'll do, we'll simply create 2 different arrays, left product and right product of n size, which is the size of the original nums array. And we can achieve this particular thing using these 2 for loops, right? So which eventually means is that first of all, you store 1 at the 0th index, and for the right product you store 1 at the last index, right? And now we will try to start from this 1 index, and what we'll do, we will basically try to multiply these 2 numbers. Okay, 1 into 1 will be 1, then 1 into 2 will be stored at 2, then 2 into 3 will be stored at this point index, like at this index, and then 6 into 4 will be stored at this index. So we are really not considering this particular element, like at any point in time, at any index, we are not really considering that particular element at that particular index. So say for example, if here is 4, so I am not really multiplying this 4 with the left product sum so far. I am making sure that except this element, I am storing the product of all the elements which are to the left at this particular index, right? So at any point in time, let's say for example, if at 4 index, I want to calculate what is the left product. So I can simply say, okay, whatever the 4 index value is there, we can simply get that. So this will give me the left product array. This is very simple, right? So we will try to run a loop from 1 till the last, like to the left product dot length. And what I'll do, I'll simply say, okay, the left product I minus 1 into nums of I minus 1. So at any point in time, I am doing that, right? So I hope this part is clear, like how we are calculating the left product. And similarly, we will calculate the right product. So right product is again same. So first of all, initially I will store 1 over here, and then I will start calculating from this point in time, right? So to calculate this value, what I will do, I will simply multiply this and this. So this is very simple. So I will take I plus 1 and nums of I plus 1. So 1 into 5 will be stored here. Then 5 into 4 will be stored over here. Then 20 into 3 will be stored over here. So you can see that at this particular index, at index 1, what we are storing is, we are storing the product of these values, right? So what I'm doing, I'm simply taking this value, which is 20, then 20 into 3. So at 1 index, what I'm doing is I am multiplying right product to index into nums to index, right? 20 into 3 is 60. Okay, great. So that means at any index I, left product can be fetched from that particular index only, which is because left product array stores the product of left side only. And if I want to calculate the right product, so right product is also stored at the same index, because right product array stores the product of right side array at this index, right? So at any point in time when I will be calculating my answer array, what I can do is, say for example, if I want to fetch the 0th, like what will be the product of 0 at 0 index, right? So I can simply multiply this and this simply, which will be 120. Similarly, if I want to calculate the product, what will be the product at this index 1? So I can simply say 1 into 60, because why? because we know this fact that left product stores the value, the product of left side array only at index 1, and at index 1 the right product stores the product of right side array, which is 3 into 4 into 5, which is 60 at this index. So I can simply multiply these two and the resultant will be stored at this index. So in this approach, what we are doing is we are taking big of n time, like n time to fill this array, n time to fill this array, and n time to fill this array. Other than that, we are taking n space over here, n space over here, and n space over here, right? As per the question, we can take this particular space, but we shouldn't take these two spaces, right? So in this approach, we are taking extra spaces, and that to 2n spaces, right? So this is why the time complexity for this solution will be big of n and big of n, time and space, right? If I show you the entire code for this problem, so you can see that first of all, I will create two different arrays and one answer array. I will simply store 0th index 1, and for the right product, the last index would be 1. And I will try to run these two loops, which are same, like which I have already shown to you. And I am filling this array, and then finally I am iterating on the answer array and then filling this particular answer array, and I can return the answer. Now let's look at the next approach, which is in which we won't be taking this right product, right? So let's look at that. So now in this approach, what I'm doing is I'm still taking a left product array and right product variable, right? So there will be a slight difference in the previous and this approach, right? So earlier what we were doing is we were filling this left product array and we were having a right product array also. And then the answer array we were also filling it from left to right. Okay. In this particular approach, what we will do is we will try to calculate the left product in a similar fashion that we did previously. As you can see that the code is exactly same, right? So 1, 1, 2, 6, 24, the code is exactly same, but there will be a difference of what, that this time we will be filling this answer array from right side, right? Like what we will get if we start filling this answer array from the right side. So as you can see that what we can do is we can take a right product variable, right? We can take a right product variable which can be initially set to 1, right? And now what I will do, just let's look at that, how we will fill this. Now what I'll do basically, I'll say, okay, say for example, here nothing is written, right? Let's remove this. I'll try to fill it once again, right? So now I want to fill this answer array, right? So let's see how we will fill it. Okay. So what I have to do is, so basically the left product array till this point is stored in this particular index, right? So I will take this value and I will multiply it with the right product. Okay. So I will get 24 as an answer. Now, because I will be moving to the next value, I need to make sure that this right product should be multiplied with the current index value, which will make this right product to be 5. Okay. So as soon as I will be moving from right to left, I will keep on multiplying my right product. Like I will keep trying to store the right product so far. And now as soon as I move to the next index, now once again, I have the left product at this index. So you can see at this index, the left product is actually 6. Okay. So I will take this 6 and I will multiply this 6 with this 5. So eventually I will get 30. And at the same time, before moving to the left, what I will do, I will take this value, which is 4, and I will multiply with this, which will make it actually 20, right? Great. Now I will move to the next element. Once again, at this index, I know that the left product so far is stored at the same index, which is 2. And then I will take this 2 and I will multiply with this right product. So this will make 40 as a value. Okay. And before moving to the left, actually, I will make sure that I multiply this index value, which is 3, to this. So this will make it 60. Great. Now I will move to the next index. So now the left product so far is stored. You can see that left product so far and at this index is basically stored at this point in time, which is 1. And then I will say, okay, 1 into 60, because right product is now stored in this right variable. As you can see, 5 into 4, which is 20, 20 into 3 is 60, right? So 60 into 1 which will be 60. And before moving to the left, actually, I will make sure that I will multiply this 2 by this value, which will make it 120. And once again, like left product is 1 and 1 into 120 will be 120. Okay, great. So in this, as you can see, like this is same. So 120, 60, 40, 30, 24, this is same. Now in this question, like in this approach, what I have done is I have taken only a left product and an answer array, right? A left product and an answer array. Okay. And then big of n and big of n, because I am still taking n space extra, right? The time complexity is still big of n, but I am still taking a big of n extra space. Now, one thing to notice over here is, am I making any change to this left product? You just think about it. I used it once and now I moved forward, right? I moved forward and then I used it, and then I moved forward and then I used it. Then I was really not using these two indices, right? So which means that can I use this left product only to store the answer itself, right? Can I use the left product only to store this answer array? Because I'm really not using these values again. If I have processed this particular index, I'm really not using it, right? I was using it only once, right? I hope it is making sense. So let's try to look at that particular approach also. If you want to see the code for this problem, so let me show it to you. So you can see that now this time I'm taking a left product array, and this is the right product, which is set to 1 now, right? The only difference is that this time I will start filling this answer array from the right to left, right? So left product of 0 is 1, and I'm calculating the left product array in the same fashion that I was doing previously. And this time I'm simply filling this answer array from left to right, and at the same time I'm trying to update the right product, which I'm calculating like so far right product I'm storing this right product variable. Okay, great. Now let's look at the next approach, which is the effective one, in which we are really not using any extra space. Okay, so let's look at that as well. Now let's look at the approach 3, in which I will be using a left product array as an answer array only, right? And the right product variable. So let's initiate a right product variable. So let me write it over here, right product, which will be set to 1. Okay, which will be set to 1. Great. And now what I will do, I will first fill this left product. So let's try to fill this left product in a similar fashion that I have done in the previous two approaches, right? So initially this will be set to 1, and now I will start filling it from here, and I will say, okay, just take the previous value and the previous value from here also. So 1 into 1 will be 1. Then to fill this value, I will say 2 into 1 will be 2. And then to fill this value, I will say 2 into 3 will be 6. And to fill this value, 6 into 4 will be 24. Great. And now what I'll do, I'll simply try to iterate on this array only from this right side only. Okay. Now what I'll say, just think about it. At this point in time, your current left product is the product of entire left side array. You can see that, which is 24. And if I multiply this 24 with this right product, this value will actually become 24, right? So let me write it like this, 24. This will become 24. Okay, or let me take some other pen. So this will become 24. Okay, great. Now, but before moving to this left value, I will make sure that the right product is multiplied with this current num value, which will make it 5. Great. Now let's move to this value. Once again, at this point in time, the left product says or gives me the product of its left side, and this right product stores the product of right side value. So at this point in time, I will simply take this 6 into 5, which will make it 30. Great. And I will make sure that before moving to the left, I multiply this 4 with this right product, which will make it 20. Great. Now let's move to the left. At this point in time, you can see that left product value gives me the product of left side array, right? Gives me the left product of left side array, and this right product gives me the product of right side. Okay, this variable gives me the product of right side array. And what I'll do, I'll simply say 20 into 2, which is 40. So I'll simply take this value 40 and I will store it over here, right? Great. And now before moving to the next value, I will make sure that I will multiply this 3 with this right product, which will make it 60, right? And then now what I'll do, I'll simply say, okay, the left product value is basically stored over here. So I'll simply take this value 1 into 60 and I will store it over here. So 60 will be stored over here. And before moving to the left, I will make sure that I will multiply this 2 with this value, which will make it 120. Great. And now you can see that there is nothing to the left, right? So the product by default will be 1, and I'll simply take this value 1 into 120 and I will store it over here, which will make it 120. And before moving to the left, I will make sure that I will multiply this 120 with 1, which will make it 120. And now the array would be ended, and you can see that we haven't really taken any extra space in this particular test case, in this particular approach, and the time complexity will be big of n and the space complexity will be big of 1, right? Great. So now let's try to code this. So what I'll do, I'll simply say, let's take a left product array, product is equals to new int, which will be a size of nums.length. Great. And let's try to fill it, right? So let's try to fill it. I is equals to 0, or let's do one thing. Left product of 0 will be 1 by default. And let's try to iterate left product dot length I plus plus, or you can run the loop till nums dot length also, that is also fine, nums dot length. Now what I'll do, I'll simply say, okay, left product will be, left product of I will be the left product I minus 1 into nums of I minus 1, right? Because I'm really not considering the current element. I'm just making sure that I need to take the left product to the left elements only, right? Great. Now let's do one thing. Now let's take right product. So right product will be by default 1. And now I will once again iterate from nums.length minus 1, because I need to start from the last index, and I should be greater than equals to 0 and I minus minus. And now I need to make sure that I will be filling this left product of I, which would be nothing but the current value which is stored already there into the right product, because right product holds the right product so far. And as soon as I store this value, I need to make sure that I update the right product also. So the right product will be nothing but the right product into, right product into whatever current nums value. So before moving to the left value, make sure that you multiply the right product with the current nums value. And that is it. And now we can return actually left product. So let's return this. And now let's try to run this. I hope this should be fine. So this is accepted. And now let's try to submit this. And here we go. So it got submitted, right? So it's very simple, I think. So we initially started with the brute force solution. Ideally, the brute force solution for this particular problem would be like when you calculate the product of the entire array, right? First calculate the product of the entire array. And then every time you going at any index, just divide the entire product by that particular value and store it there, right? So that would be ideally that would be the brute force solution. But because in the question itself, it says that you cannot use division operator. So that is why I'm not calling that particular solution as a brute force solution. So brute force solution is when you are taking left product and right product array. Then I'm reducing the space by big of n, but still the space complexity would be big of n only. And then finally, we are completely avoiding using the extra space, and then we are only using the answer array, right? So I think this is it from my side for this video. So I'll see you in the next video. Till then, bye bye.